Good morning, welcome to the chemistry taster session. My name's Jack Royal, or Mr. Royal. If you attended the Welcome to QE Day just before the Christmas holidays, you may have noticed me in the talks then. So during this session, we're going to have a look at some of the A-level chemistry content. It would be useful to have a bit of paper just to write a couple of things down, but obviously it's entirely up to you as we're doing this virtually. At the end of the session, I'll hopefully have a chance to answer any questions for you. So again, just for those of you that have just joined, if you could have a little bit of paper to hand and just might want to jot a couple of things down as we go through. If we can save questions and answers to the end of the session, that'll be great. So in this session then, what we're going to be looking at is an overview of the required practicals. We're looking at some of the inorganic test tube reactions, which you cover next year, and also in your second year of A-level. And then we're going to, at the end of the session, look at your understanding of these inorganic test tube reactions and link it to the A-level specification. So up on the screen then, if you attended the open day talk, the virtual open day in the autumn term, you will have had a look at some of these required practicals or a list of them. Let me just go through a quick overview with you now. So in all of the A-level sciences, biology, chemistry and physics, there are required practicals that you're required to carry out in order to get a pass in the practical side of the course. At A-level chemistry, you do the first 6 in your first year or year 12, and then the second 6 in year 13 or the second year. So next year there's simple acid-base titration, measuring enthalpy change, looking at how the rate of reaction changes with temperature, some simple test tube reactions, distillation, and tests for some organic compounds. So lots of those will sound familiar to you because they're covered in most GCSE specifications and syllabuses, depending which one you've studied this year and last. So the purpose of A-level is to build on the knowledge and the skills that you develop at GCSE to prepare you for higher education or prepare you for university life. Just looking at the second 6, so looking at 7 down to 12, these are year 13 practicals or second year practicals, where we look at rate of reaction in more depth, where we look at how batteries work. So we're looking at voltage across a cell. So there's a little bit of physical chemistry in there. Looking at investigating pH, preparing organic solids and liquids, and then carrying out simple test tube reactions and thin layer chromatography. So again, some of these things may seem familiar to you, but obviously at A-level, we build on what you've looked at GCSE and before in a lot more depth to help you prepare for university. So in today's session, we're going to be looking at required practical 4. So required practical 4 is linked to the group 7 ions test. So the group 7 ions test is something that you may have looked at GCSE, where you test for the halide ions. That's chloride, bromide, and iodide. So I've copied this directly from the specification so you can see what is expected of you at A-level. We're going to go through those test tube reactions. I'm going to play you a short video shortly. And then I'm going to give you an unknown compound and ask you to try and deduce what it is. Try and work out what that compound contains. So you should be aware that silver nitrate is used to identify halide ions. Don't worry if you can't remember, the video will go through each of those. But then at A-level, we also look at how silver nitrate is acidified. That's where you add an acid. So this word here, acidified, means you add an acid. And then how ammonia solution is used to confirm the halide. So I'm going to be playing you a short video of me doing the practical. I thought it was better to pre-record it so you could see the observations a little easier. Saves me moving the camera around as I do it. It might be worth just making a few notes, just scribbling down a few things as I'm talking through it. And once again, we're looking at chloride, bromide, and iodide ions and their observations with silver nitrate and ammonia solution. We're also looking at carbonate ions, which we can see down here, and the test for those. Some of you may be familiar with that already, but again, don't worry if not, because the video will go through each of those. So I'm going to play the video, jot down a couple of things. The second part of the video will have me carrying out a test on an unknown solution. And then afterwards, I'm going to give you a few questions. They're just multiple choice questions, so there won't be loads to write down, but you do need to understand what's going on, so it would help. So I'm just going to share my screen with you. The sound quality is a little bit low, so what I'm going to do is talk over the video instead. You might still be able to see my face. So this was pre-recorded yesterday, and it's just me carrying out the reaction. So what we've got from left to right, we've got chloride, bromide, and iodide, and then a solution of carbonate. So potassium chloride, potassium bromide, potassium iodide, and sodium carbonate. So the 3 halide ions on the left. You can see the bottles are just behind them, and then sodium carbonate is in the right. To start off, to carry out a chemical test with the halide ions, we add nitric acid, and you can see that's in that big bottle there. So I'm going to add some nitric acid to each of the 4 test tubes. And this is acidifying the solutions. So the acid ions, the H+ ions, are removing any impurities that may also form a precipitate. I'm now going to add the acid to the sodium carbonate, which I'm just holding up here. Acid plus carbonate should form effervescence. Now this isn't the best quality, you can't see that many bubbles. So effervescence means fizzing. And if you add acid to a carbonate ion, you should see fizzing, or the proper word is effervescence there. I'm going to show you this live as well, just so you can see the fizzing a bit better later on. But you might see a few bubbles just rising to the top there. So when you add an acid to carbonate ions, you get fizzing, and that confirms the presence of carbonate. Can you remember the gas that's produced in that case? So now that I've added acid to the carbonate solution and I saw effervescence or fizzing, I don't need to add any more chemicals to that. To distinguish between the chloride, the bromide, and the iodide, I'm going to add some silver nitrate solution. So I've got chloride solution, bromide solution, iodide solution. I'm now adding silver nitrate, and I should get a precipitate formed. You might remember the term precipitate from your GCSE. So you can see there we've got 3 different precipitates. The chloride is a white precipitate, which you can see a bit clearer if I hold a bit of white paper up against it. The bromide is a cream precipitate when you've added silver nitrate. So you can see it's not quite white. And the iodide is a yellow precipitate. So if you line those up together, you should be able to see white precipitate, a cream precipitate, and a yellow precipitate. However, this is where we build on the GCSE knowledge. So you might remember white, cream, and yellow precipitates. But lining them up, they all look quite similar, don't they? So what we need to do here is carry out a further test, and that additional test will help us to distinguish between the 3. So if you just looked at the bromide one on its own, is that white? Is it cream? Is it yellow? So to confirm this, we can add ammonia solution. Might remember the formula of ammonia. It's NH3. And in solution, the NH3 can dissolve the precipitates. So again, I've just paused it there for you to take it in. We've got a white, cream and yellow, fairly similar colours. So to distinguish between the chloride on the left, the bromide in the middle and the iodide on the right, I'm adding ammonia solution to see if the precipitate dissolves. So I'm starting off by adding dilute ammonia. So low concentration, it's quite dilute, quite weak. I'm adding that to the chloride precipitate. And you can see, this is the important bit, dilute ammonia has caused the chloride precipitate to dissolve. So the chloride precipitate is no longer present because the dilute ammonia has dissolved it. If I add dilute ammonia to the bromide precipitate, you can see the precipitate is not dissolving at all. And if I add the dilute ammonia to the iodide precipitate, you can see the precipitate is also not dissolving at all. So the chloride precipitate, silver chloride, which was white, has dissolved in dilute ammonia. Bromide and iodide have not dissolved in dilute ammonia. So what we can do is add some concentrated ammonia. Now this chemical is pretty horrible. It's very corrosive and gives off some very smelly fumes. So you might be aware that we need to carry that out in a fume cupboard. So what we've got here, there's the dissolved chloride. I don't need to do anything with that. I've got my cream precipitate and yellow precipitate, bromide and iodide. And I'm going to add some concentrated ammonia. You can see here I've changed from the desk to the fume cupboard so that I don't breathe in the corrosive and harmful vapours of ammonia. So concentrated ammonia has a lot more NH3 molecules present in it. If I add concentrated ammonia to bromide, you can see the precipitate has dissolved at the top. So a good chunk of the precipitate has dissolved when I add concentrated ammonia. If I add concentrated ammonia to the silver iodide precipitate, give it a little shake, and you'll see the precipitate's not broken down at all. The precipitate remains there. So just to summarise, this is the bit that's new. This is the bit that we build on at A level. I'm just getting you familiar with it now. Silver chloride is a white precipitate. It dissolves in dilute ammonia. Silver bromide, cream precipitate. It dissolves in concentrated ammonia. That's the stuff in the fume cupboard. Silver iodide doesn't dissolve in either the dilute or the concentrated ammonia. So let's have a look. I'll answer any questions at the end if that's all right, Kira. So let's have a look at the unknown. And again, there'll be a couple of questions on this shortly. So try to pay attention, make some relevant notes if necessary. So following on from what we've looked at, those different observations, I've now got a solution that contains some unknown ions. and it's up to you to deduce, to work out which ions are present. This is the sort of thing that you'll be looking at quite a bit at A-level, is working out and analysing, problem solving, and that's part of the required practicals. So I'll just talk over it as I do it. So we've got an unknown solution. I'm going to start by adding some nitric acid to that unknown solution. So when I add nitric acid, you can see some bubbles, a bit clearer this time. You can see some effervescence in that solution. So I've added acid and I saw effervescence. So which ions must be present? I'm then going to add some silver nitrate. And you can clearly see a precipitate forming. Now, what colour is that precipitate? I mean, it looks white, but it could quite easily be cream, so I'm not too sure there. So I've got effervescence with acid. I've got a white precipitate or a cream precipitate with silver nitrate. And just to confirm the presence of that precipitate, I'm going to add some ammonia solution, give it a shake, and you can see the precipitate has dissolved in dilute ammonia. So let's just summarize those three observations. I added acid, there was effervescence. I added silver nitrate, there was a precipitate that was probably white. I confirmed that it was a white precipitate because it dissolved in dilute ammonia. So using the information we've looked at, let's try and work out which ions are present. So let's go back to the PowerPoint and let's have a look at some questions. So I'm going to go through step by step a few multiple choice questions. If you just write down the letters, and you can check if you've got them correct afterwards. Once we've gone through those answers, I'll give you a few minutes for any questions and answers. So question number 1. What are the names of the products when I react silver nitrate and potassium iodide? So silver, iodine, potassium, nitrogen, potassium nitrate, silver and iodine, silver iodide, potassium and nitrogen, or silver iodide and potassium nitrate. If you're not sure, have a guess, but it's one of those 4 options there. And then question 2, which you can see there, which one of them is the correct equation if I reacted silver nitrate with potassium iodide? So choose one of the 4 options. Let's give you 20 seconds or so to finish answering those. Okay. Question number 3. When I had my silver nitrate and my potassium iodide and I mixed them together, what would the correct state symbols be for that? So A, B, C, D, or E? So what would the state symbols of the silver nitrate and potassium iodide be? Based on what I did in the video, I had a test tube containing one and I transferred the other one using a pipette. And then question 4, what is the observation if I added silver nitrate to sodium or potassium iodide? Which of the 4 observations would I make if it was iodide ions? white precipitate, cream precipitate, yellow precipitate, or effervescence? So again, just 10 multiple choice questions, just asking you to see if you understand the video, see if you can interpret what we've looked at. Question 5 and question 6. Again, we're focusing on sodium or potassium iodide. When I add silver nitrate to the iodide ions, what is the product that I would observe? So what's the state symbol of the product? Solid, liquid, gas, or aqueous? So write down the letter and we'll go through the answers in a couple of minutes' time. So question 6, I've got my test tube, I've added my iodide, I've added my silver nitrate. What's then going to happen if I added ammonia solution to it? So if we've got an iodide ions, I've added silver nitrate, what would happen if I added ammonia? Would there be fizzing? Would the precipitate dissolve in dilute ammonia? Would it dissolve in concentrated ammonia? Or would it not dissolve at all? What I can do, I can share this PowerPoint afterwards. I'm happy to send this around. I can get your emails, so I can get this posted to you via email following this session. So questions 7 through to 10 relate to the unknown solution. So question 7, when I added silver nitrate and acid, what did I observe? Was there effervescence or no effervescence? That means fizzing or no fizzing. Did I get a white precipitate, a cream precipitate, or a yellow precipitate? So which one of these is the correct answer there? So again, with the unknown, what did you see there? So that's a very good question there that I've just read from Albert. If you added concentrated ammonia, then it would dissolve the bromide and the chloride. So adding dilute ammonia first helps you to distinguish between chloride and bromide ions. But yeah, you could add concentrated first and that will completely tell you straight away which one iodide is. Question number 8 and question number 9. So when I added ammonia solution, which of the following options was correct? Precipitate dissolved in concentrated ammonia, precipitate did not dissolve, or the precipitate dissolved in dilute ammonia. And therefore, which ion or ions were present in the unknown solution? Bromide, carbonate, iodide, or chloride? You may choose more than one answer for this one if you wish. So as time is ticking down, we've only got a few minutes left. I'm just going to whiz through the answers to those. But once again, I'm happy to share this PowerPoint so you can look at the answers in more depth later on. There's also an exam question on this PowerPoint so you can see the sort of knowledge that you'll be assessed on. So let's have a quick look at the multiple choice answers, and then I've got a couple of minutes and I'll just quickly read out your questions. So question 1 and 2, you should have had D and C. So you can give yourself a tick or a cross if you got it. Question 3 and 4. You should have had B and C. So well done if you got those. Question 5 and 6. You should have had A and D. Question 7 and 8. 7 you should have had A, so there was fizzing followed by a white precipitate. And then 8 and 9, the precipitate dissolved in dilute ammonia, and so the two ions that were present were carbonate and chloride. So really well done if you managed to deduce that or to work that out. So again, I'll share this PowerPoint with you so you can look through those answers a little bit more later on. We've just got a couple of minutes left, so I'm going to read out your questions. I'm sharing this PowerPoint with you so you can have a look at this exam question up on your screen, and it's got the mark scheme there as well, so you can see where you'd get the marks for at an A-level standard. So just 2 or 3 minutes and I'll just answer these. So the first question says, what exam board are we using for chemistry? And that is AQA. They're a really good, well-resourced exam board. Lots of exam questions available, lots of resources available to support students. And lots of people do that at GCSE as well. Answered Albert's about the concentrated ammonia. Lamia, I think it is, which chemistry textbook or revision guide do you recommend us to buy? What I can do is I can share some links in that email, so I can send some possible ones in there. And I think I can see a couple of people asking that. A-level topics, there's a lot of topics at A-level chemistry, but it's split into inorganic, like test tube reactions. It's split into physical chemistry, which is like your calculations, and then organic chemistry. And again, I'm happy to share anything in this email, so I'll attach the specification in there. Classes are just sorted based on timetable, so there's no streaming or setting at A-level. So again, I'll share some resources on revision guides. I've got a few more questions. I can just manage one more. So I'm just finding a good one there. So practicals are assessed. You get 3 papers at the end of 2 years, and the 3rd paper is based on your understanding of practical chemistry. But you get a certificate for practical chemistry there. So you can see up on the screen, if I haven't answered your question, I do apologize. What I can do is I can put my email address in this email that I'll send to you later. So if I have not answered your question, then feel free to get in touch with me and I'll reply to you before the end of term. Otherwise, if it's a more general query, if you go to admissions@wqe.ac.uk. Thanks for your time today. Hopefully that was useful. I know we only had half an hour, but we did cover a fair bit. So feel free to head off. I hope you enjoy the rest of your sessions today, and I'm looking forward to welcoming you here next year. Thank you, everyone. Bye-bye.